This meeting is being recorded.
Okay, from our previous class, we discussed about how does the switch function in connecting four devices, four PCs. We talked about broadcast, multicast, and unicast. We talked about separating, the layer 2 versus layer 3 in terms of the MAC address table and the ARP table. We talked about how does the broadcast works in terms of sending the first packet when the destination MAC address is unknown. And then after the MAC address is known, it will be using the unicast messages to make them communicate. So we will continue the switching fundamentals today, but we'll talk about separating the broadcast domains, attaching different broadcast domains to the ports. And then we will also talk about allowing multiple, VLANs on a specific link or the trunk link to make them communicate. Okay, so let's start. We take a switch and then so I'm going to bank on the same example. I took a switch and I have taken four PCs, PC1, PC2, PC3, and PC4. Okay. Yesterday, when we talked about communicating between the PCs, we discussed about having, when the PC1 is trying to talk to PC4, or PC1 is trying to talk to PC3, or PC1 trying to talk to PC2, we talked about the first message being broadcasted. But now we got a requirement that we don't want the packet to be broadcasted to every PC. We wanted to limit the broadcast domains. Meaning, let's say, now this PC, let's say this is in accounts department. And this PC3 is in accounts. PC2 is in sales. And PC4 is in sales. Now, we wanted to limit the communication between departments. So PC1 should only talk to PC3 and PC2 should only talk to PC4. So initially, we wanted to make sure that this is one domain and we wanted to make sure this is another domain. So when the PC1 sends the broadcast message to the switch should only broadcast that message to only those ports inside that broadcast domain. It should not broadcast the same message to PC2 and PC4, right? That should not be done. Similarly, when the PC2 is sending a broadcast message to the switch should broadcast to only the other ports inside the same domain. When I mean domain, I'm calling this as a VLAN. VLAN, which is nothing but virtual local area. So if I consider this whole setup as a LAN, which is the local area network, local in a specific region or a specific place, I'm separating them into two different groups, and that is nothing but VLAN. So the behavior of a switch is initially there is no VLANs on the switch. When you send the packet, it will broadcast to all the ports. But when you start separating them into different broadcast domains, you are creating VLANs on the switch and you are attaching VLANs to the port so that they will be in that broadcast domain. So you as an engineer, when you configure, you will define the VLAN, you will define a VLAN number. Let's take this as VLAN 10, and you will define a VLAN name as accounts department. Similarly, you can pick a VLAN number as 20, just an example, and you can name it as sales. And you will attach port number 2 and port number 4 in VLAN 20, and you will attach port number 1 and port number 3 in VLAN 10. So that way, we are separating the broadcast domains. So by doing this way, we are making the switch broadcast domain into different groups. Is that clear?
Yes, sir.
Could you please explain it once again?
Which part?
Before the VLAN, sir. I mean,
Like how it's dividing.
Yeah, bit the concept little bit confusing, sir.
yeah.
Okay. Let's do one thing. So there is a person announcing a message, and here the person is announcing a message. So think about this is like a big auditorium, and the auditorium has 3 rooms in it. So when this person wants to send a message, either he can send the message to group 1 or group 2 or group 3, right? But without groups, he will send a message to the entire auditorium. Okay. So, but in this concept, we are separating the auditorium into multiple rooms. For example, think about this is like a room 1 or group 1, room 2 or room 3. So if you want to send a message, you can send only to a specific room, not to the entire auditorium. Okay. So now you understand the concept of groups. Similarly, a switch will have like port 1, port 2, port 3, port 4, port 5, port 6, port 7, port 8. So there are different groups on the switch. When a PC1 is connected to port 1, when there is no VLAN, that message is sent to all the ports.
So what you're saying is like here where VLAN is used so that the message could particularly send to just one group that we wanted to send.
Yes.
Is it all or?
Yes. So when we have the VLANs, you are separating them into a group. When the PC is sending that message on the specific port, that is sent to all the ports in that group only, because you are attaching a VLAN to that port. So on the switch,
Sir, VLAN itself is a partitioning of systems, we can say that.
so on the switch, there is port 1, port 2, port 3, port 4. So when you are attaching a PC to the switch, you are putting this port in VLAN 10. So when the message comes into the switch, that message will be replicated on all the ports, like sending that as a broadcast domain whichever ports are in the same VLAN. If you attach the VLAN 10, that message will be sent to all the ports on that VLAN. But if you are tagging that with a VLAN 20, that message will not be replicated. So in our previous class, we talked about having just one VLAN, all the ports will be on that VLAN, so the message will be sent to all the ports. But when you're separating them into different VLANs, when a message comes into that specific VLAN, it will be sent to all the ports in the same VLAN, not to every VLAN. So we are just making partitions on the switch.
So here, like we're attaching a VLAN to like two different ports, right? So let's say the port 1 will be connected to VLAN and the port 4 will be connected to VLAN, and the data will be delivered to only these VLAN VLAN 10, right?
Yes.
Yeah. So like, do we need to connect VLAN 10 to like individually to all the different ports, or like if one port is okay? See, one VLAN is okay.
It depends on the requirement. When you do multiple VLANs, it is necessary to apply one port to one VLAN. Depends on your number of groups. If you have multiple departments, you will have multiple ports, right? You're gonna put one port in each VLAN. So if you have sales, if you have like marketing, if you have like accounts, you will attach that specific port in that VLAN.
Okay.
So we do have the VLANs with the different addresses, right? Then only we can identify with the different PCs when we attach with the multiple VLANs.
I'm sorry, what?
Like we have, as you said, like it's connected through a switch with the two different PCs with the VLAN 10. If we're gonna have multiple VLANs, so its address gonna be changed, or it's gonna be the same address?
Why does the address came into the picture now?
Like you said, like VLAN 10 and VLAN, it's connected to two PCs in before example, right? So when we use multiple VLANs, will that be the same?
You're talking about the IP address, correct?
Yeah, yes, sir.
Okay. So if you are using multiple VLANs, they can be part of different addressing spaces, like two different groups. Okay. But each PC will have its own IP address, right?
Yes.
Right. So when you are creating VLANs, you are making them into groups.
Okay.
So can we call it as multicasting, sir?
No. Multicasting is like you are sending a group address, but here you are separating your broadcast domain into smaller broadcast domains. You're still broadcasting, but to a smaller broadcast domain.
Like broadcast in a sense, if we send message to one port, it will broadcast to every PC.
Correct.
But here,
But hold on. But in this case, you are broadcasting to only that specific members in the group.
yeah, it's as we discussed yesterday, one to one group. It can be termed as multicasting, right?
No. So multicasting is sending one message to a group address.
Yeah.
But here we are still broadcasting, but broadcasting to a smaller group.
Without mentioning address, IP address.
Yes, without mentioning the multicast IP address.
Okay.
Okay, sir.
So once if we mention the IP address, it goes to multicasting, sir.
Once you send the message to a multicast group, that is a multicast,
Yes.
which is a multicast IP address.
Okay, basically, it will communicate according to the ports, not through the IP addresses, right?
No, I think you guys are pretty aggressive on the questions. Give me 1 second. Let's take a step back. Okay, so let's pick So I'm sending this message to a group address, right? So this group will have an address. For example, this group can have 239.0.0.40. So here I'm sending the message from one to this group, and all the devices in that group will be listening on this IP address. That is multicast. But I'm not talking about multicast here. I'm talking about, I'm still doing the broadcast, but I'm grouping the ports into a specific VLAN, which is a layer 2 component. Here, I'm not using the IP address to send my message. I'm still broadcasting, but I'm limiting my broadcast to a specific number of ports.
Got it, sir.
Okay, going back to the VLAN concept. So I'll take a switch. I'm gonna take PC1, PC2, and PC3. Or let's take, okay, 3 PCs are enough. Okay, so this PC, okay. So this is PC1, this is PC2, and this is PC3. So this is port 1, and I configured on this switch port VLAN 10. Okay, so I created a VLAN on this, and I put this port in VLAN 10. So this PC3 port 3, I put it as on VLAN 10. Okay, and this PC2, I'm gonna put this as on port 2 on VLAN 20. Okay. From our yesterday's class, we talked about PC1 broadcasting the message to the switch. Now, if there is no concept of VLAN, this would have broadcasted to PC2 and PC3. PC2, if it's trying to reach PC3, PC2 will discard and PC3 will respond back, and that response will go to the PC1. That is yesterday's example. But today, we divided them into different VLANs. So because this message received on switch on VLAN 10, it will be sending that message to only VLAN 10 port, but not on VLAN 20 port. Because it is marked as VLAN 10 on the switch port, it is going to send to the other ports on the same VLAN 10 only. Is it clear now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. All right. So that is the concept of attaching a VLAN to the port. By attaching a VLAN to a specific port, we are limiting the broadcast domain. We are separating a big broadcast, meaning when I mean a big broadcast, I'm sending one message to all the devices on the switch when there is no concept of VLAN. But once I separate them into VLANs, my broadcast domain is getting smaller, so that that message will be sent to the ports only in that specific VLAN. Okay, so now let's talk about access port and trunk port. So here on switch, I have a port 1 and I have a port 2. Okay, so what I'm going to do on the switch, I will create a VLAN 1 or VLAN 10 and VLAN 20. Okay, so when I attach a specific VLAN to a specific port, and this port is called access port. So attaching a single VLAN to an endpoint where when I mean endpoint, the end user machine, like can be PC, printer, server, whatever it can be, attaching the end user machine to the port where I can attach the VLAN, a single VLAN is called access port. Okay, so attaching a end user machine to a specific switch port with single VLAN mapping is called access port. Okay. So that is the concept of access port. So we have an end user machine like a PC, and we are attaching a VLAN to that specific port, and that port is called an access port. Okay, now let's talk about a trunk port. Allowing multiple VLANs on a single link is called trunk port. Let's see the use case of this one. I'll talk the definition a little bit here in a second. So now let's take two switches now. Okay, this is switch 1 and this is switch 2. I have a PC 1. Okay, so this is VLAN 10. I'm going to change the color. This is VLAN 20. Similarly, on switch 2, we have VLAN 20. And we have VLAN 10. Okay, and there is a link between them. Now let's see the traffic flow here between these two PCs. So now when the PC1, this is PC1, this is PC2, this is PC3, and this is PC4. Now PC1 wants to talk to PC3 in the same VLAN. So when the frame comes in from the PC1, the switch will broadcast that frame to the interface on the same VLAN, correct? So now this port what we should do is we should allow both VLANs, both VLAN 10, 20. Okay. So in that case, what it will do, it will use a tagging methodology. Think about like having a green tag and red tag for your frame. When the packet comes in, this will send the green color tag, VLAN 10 tag, so that the frame will reach all the way to the switch 2, and it will broadcast to the ports which are in VLAN 10. So it will broadcast that to the VLAN 10 port. And if the VLAN 20 frame comes in on VLAN 20, on the access port of VLAN 20, it will go with the red color tag and it will broadcast to the red color access VLAN 20 port because it is tagged with the VLAN 20. So that way, VLAN 20 will be able to communicate with VLAN 20, and VLAN 10 will be able to communicate with the VLAN 10 because this link is passing both the VLANs by having a tag value. The tag value is VLAN 10 and the other tag value is VLAN 20. So allowing multiple VLAN tags on a single link is called a trunk port. In our example, this middle link is called the trunk port, and these ports are the access ports. So attaching an end user machine on a specific switch with single VLAN mapping is called an access port. But when we are allowing multiple VLANs on a single link, that is called trunk port. And this is called encapsulation. So what is encapsulation? Meaning like you have, think about like having a link. Inside that link, I mean, think about like having sending a courier. So you are sending a courier, but inside that courier, there will be letters inside that one. So you are sending data, but inside that courier, if you open the courier, there will be multiple letters inside of it, right? You never know what is inside. So here, this might be a single link, but inside that, we are sending VLAN 10 and VLAN 20. So that is called encapsulation technique that we are using to send the data, which can be either VLAN 10 or VLAN 20. That is differentiated using the marking value. So with VLAN 10 or VLAN 20. So that is the concept of trunking, where we allow multiple VLANs on a single link. Any questions?
Sir, for example, PC1 in the switch 1, when it sends a green signal to the switch 2, it tries to communicate with PC4 or only directly goes to the PC3?
It will broadcast only to the ports on that specific VLAN. Here in this
Okay.
case, it will try to send only to PC3. It will never
Yeah.
send message to PC4 because it's in a different VLAN.
Okay, so when the green tag is sent it goes only for the green LAN.
Correct. Correct.
Okay, it doesn't even try to communicate with the red tag
No,
because those are identical. Like, yeah.
because they are separated with the tags.
Yeah, yes, I got it.
Yeah, understood. You got it. Yes.
So there is nothing to do with the ports here, sir. Basically, in the first example that where you said about the access port, we have differentiated with port 1 and port 2. Here, like we are just dealing with the tags. So will the ports play any role here, or like only we need to go with the tags?
Question is not clear. What do you mean by playing with the role?
No, sir. Like, see, in the access port, like we said that so the VLAN 10 and the end user like computer are connected to a port 1. So here, like we are only just talking about the tags in the trunk port.
No, even here the ports are there, right? Switch
Yeah.
1, port 1 is connected to PC1.
Yeah.
Switch 1, port 2 is connected to PC2.
Yeah, that's the
But
only
we
question.
are attaching the VLAN to that specific like a access port. I
Okay.
mean, if you observe, this is still an access port here, and this is also access port here, right? There is no
Yeah.
change.
Yeah, that's the only question. Like, do we have an access port here or not? So I just want to check.
We do, yes, we do have access ports here. The access port is where we are tagging the VLAN, but trunk port is where we are allowing both the VLANs.
Both the VLANs, yeah.
Yes.
Yeah, thank you.
Yeah, so sir, like tag is nothing but the name of the PC that we are giving. I mean, the VLAN just it's a naming convention. That's why we are calling it as a tag, right?
No, it is not a name. So if you look at the Ethernet frame, we talked about ones and zeros, right? So let's say your frame that you are trying to send from here to here is ones and zeros, that like it's all ones and zeros at the end of the day. So for ones and zeros, you are attaching one more ones and zeros, so that will have a tag of 10. If you convert the tag of 10 to hexadecimal system, that is what? 0 to 9, and then you will see a value of A. A means 10, B means 11, C means 12, D means 13, and E means 14, and F means 15, right? So here, when you send the 10 value, you will see the tag as A. If you send the VLAN 20, you will see the value of, that will be what? That should be counted into hexadecimal. So that will be, let's do that. 2 power 0 2 power 1, 2 power 2, 2 power 3, 2 power 4. I think that is enough, right? So 16 plus 16 plus what? 4, 0, 1. So 1, 0, 0, 0. So you will send this as the value of 20. Right? You got it?
Yeah, so it's nothing but for a frame, we'll be adding a tag
Yeah,
like
extra tag value with this value, it is attached to the frame. That way it is separated. I mean, at the end of the day, switches does not know about names or anything. It just considers ones and zeros, right? So we are adding a tag value to the frame that is separated. So if I show you, well, let me visually show you, so you'll understand what I'm talking about. So if I share the screen. Ethernet frame, VLAN tag. Okay. Let me show an example that will make sense. Okay, let's pick this one. So if all right, now my let me pick another one in this one. Okay. But I'm running out of luck. 1 second. Not this one. This one should work. Okay. All I wanted is to zoom this one. Okay. So if you see, the tag is like a header that is attached to the Ethernet frame. So it's like 4 bytes. So this value is attached to the header. If you are sending like source address, destination address is just the MAC addresses. And with that MAC address, we are attaching a header value. Inside that header, you will have like your VLAN tag. It can be VLAN 10, VLAN 20, VLAN 30. It is attached in the middle. If you don't have the VLAN tag, this header is not attached. It is just a header that is attached to the frame. So initially it will be source MAC address, destination MAC address only. Based on that, we will do the unicast. But you're attaching a VLAN tag value on the switch port so that that port will be differentiated with the tag value, not just referring to the destination address. So you are inserting a tag with the header count, where you will see with this tag value, it can be number 10, number 20. Based on the number you give on the port, your frame will be differentiated. Okay, that is how it looks like in an Ethernet frame for visualization. Does it make sense, or did I confuse you more?
Yeah, I understood it.
Okay. I'm gonna stop sharing, go back to the whiteboard. Okay, so actually I think that's all. Let's go to the lab. Let's replicate what we did. Okay, this is our example. So I took 4 PCs, PC0, PC2, they should be in VLAN 10. So when the PC0 broadcasted the message, it should go only to the PC2. When PC1 broadcasted the message, it should go only to the PC3. So that should be our lab. Okay, so now let's go and define the IP addresses. Accordingly, this is 10.0.0.1, this is 10.0.0.2, this is VLAN 20.20.0.0.1, and this is VLAN 20.20.0.0.2. Okay, any questions on this setup?
No, sir.
No.
No, sir.
So do you mean encapsulation is the process of sending the tagging VLANs, or both the trunk and encapsulation means the same? So trunking means allowing multiple VLANs on a single link, but the backend technique the trunking uses the encapsulation. So you can technically say trunking works on encapsulation. Okay, so I'm going to go to the PC0 and go to the IP config. Config 10.0.0.1. Define the IP here. 10.0.0.2. Okay, so IPs are set up. Now I'm going to log into the switch. I did enable to log into the switch, enable, and then do. First, initially, I will check what are the VLANs on the switch. Okay, show space VLAN space brief is the command to check the VLANs. So I just see the default VLAN and some reserved VLANs. These are reserved VLANs which we don't use. These are reserved VLANs by the vendor, and this is the default VLAN where all the ports will be just one broadcast domain. So by default, all ports will be on VLAN 1. Okay, so that means that they are part of one broadcast domain. So now I'll do config terminal to configure it. VLAN space 10. Okay, I'm creating a VLAN number 10, and I'm defining the name of the VLAN as sales. So now if I do show VLAN brief, it's showing, okay, I have a VLAN name 10, number 10, and the name as sales. Okay, similarly, I'm creating VLAN 20. VLAN 20, and then define the name as accounts. Okay, so far I created the VLAN 10 on the switch and defined the name as VLAN 10 name as sales. So this is the sales, and this is accounts. Now I have to use these ports as access ports, right? So let's see, 0/1, 0/2. So I have to configure them. So now config terminal again, interface, fast Ethernet, the name of this interface 0/1. I have to do switch port mode. What is the port mode? Access. So this is the access port. And then I have to attach the VLAN, switch port, access, VLAN 10. So now this port is in VLAN 10. So I can check that by doing show VLAN ID space 10. It says 10, and I have the port 0/1 in the VLAN 10. Okay, so now interface fast Ethernet 0/2, switch port mode access, switch port access VLAN 10. Okay, so now what we have done, we did this port and this port in, we did this port and this port, both are in VLAN 10. Okay, so now let's go to the PC desktop. Okay, now let's check the ARP entries here. No ARP entries found. We know that this does not know any of the connected interfaces, right? It does not know any of the other PCs in the network. Okay, you can check the IP of this device. IP is 10.0.0.1 that you configured on this switch. Okay, so now what I'm going to do is I'm going to do the simulation. I'll start the simulation and then go here and then generate a ping. Okay, ping 10.0.0.2. So I'm going to send the broadcast message. So now I'm here, I'm sending a broadcast message. So the broadcast message came here. It is not sending that message to any of the other ports. It just sent that to the VLAN 10. It did not send that to the PC1 and PC3. I'm going to show it again. I'm going to delete the ARP. I mean, let it complete, and then I'll stop and start again. So I'm going to go to real time. So I'm going to go here and then check. Okay, I'm getting responses. So what I'm going to do, I'm going to delete the ARP again. ARP-delete. Okay, now if I do no ARP entries found again. So I'm going to generate one more broadcast to show that it is going to only that broadcast domain. So I'm going to go to simulation, start. I'll move it here. If you observe, if I start here, the green color packet will start from here. It goes to the switch. It will never go to PC1 and PC3. It will just go to the PC2. Okay. So I'm going to start my broadcast now. Okay. So now, okay, the broadcast started. It went to the switch. Now, technically, this should not go to PC. No, it's going only to PC2. It's not going to PC1 and PC3 because we are separating them into VLANs. So we limited the broadcast domain. Yesterday, if you observed, it would have gone to switch and go to the PC1, PC3, and PC2. But today it went only to this PC2. Okay, now let's stop this one and replicate the same on VLAN 20.
Sir,
Yes.
yeah, can we make that 10.0.0.1 as VLAN 10 and the PC2 as VLAN 20 and PC3 as VLAN 10 and PC4 as VLAN 20? You can do that?
Oh yeah, why not? Yes, we can.
Yeah, like two different parts with two different VLANs.
Yes, we can. Yes. You mean to say two different IPs?
No. Like in sales, we have two PCs. In accounts, we have two PCs. So we are
Yes.
gonna make one like PC0 as VLAN 10, PC2 as VLAN 20, and then PC1 in accounts as VLAN 20, and PC3 in accounts as VLAN 10. We can do that.
Then what's the point of doing the separation, right? If you're doing mix and match, what is the point of making them into a single group?
Oh, okay, yeah.
There should be a reason, right?
Mhm. Like before the example when we took it as like recently when like green tag and red tag in the piece in the switch 2 also it goes for one VLAN 10 and one VLAN 20, right? So I was thinking the same example here.
Well, let's do the second example as well. Let's do that
Yeah.
example as well.
Yeah,
Then you'll
yeah,
get clarity. Okay.
okay,
So
sir.
let's look at this one now. So now I'm gonna go to const VLAN 20. We already did the VLAN 20, right? So let's see the ports. 0/3, 0/4. Interface phase 0/3, switch port mode access, switch port access VLAN 20. Interface FK 0/4, switch port mode access, switch port access VLAN 20. So these two are in VLAN 20 now. We will go to here and then generate ARP. No ARP entries found. So let the interface come up. I can do show VLAN ID 20 0/3 and 0/4 in VLAN 20. So now start the simulation, start, and then go here, and then ping 20 dot. I have to move it here. 20.0.0.2. Okay, I started the broadcast, green color packet. It went to the switch. It should only go to PC3. Yep, it's only going to the PC3. Okay. So go to real time and then observe it got the responses back. So it is able to ping. So now if you look at the MAC address table here, show MAC address table, you will see VLAN 10, 0/1 and 0/2 are in VLAN 10 port, and 0/3 and 0/4 in VLAN 20 port. So the MAC address table is also separated based on the VLAN. Okay. So now I'm going to pick the second example now. So what I'm going to do is I'm going to clear a few things here. Guys, I'm extending the class for 10 more minutes because I joined 10 minutes late. I apologize if you have anything to do, but I have to complete this. Sorry. I have one more switch. So now what I'm going to do is I'm going to put this in VLAN 20. And the IP address for this one will be 20.0.1. So I'm going to make more piece here, make one more piece here. So where will be so this is VLAN 10 again. This is VLAN 20 again. So this is a trunk port. Hello, both VLAN 10, 20.
And access port.
And this is access port. Access port. Access port. Access port. Access port. Any questions on the setup?
No, sir, no, sir.
And the IP address of this one is 10.0.0.2. 10.0.0, sorry, 20.0.0. Okay, so now let's do the setup as per the, okay, so here, let's put this one. So this port should be on VLAN 10, 0/1 and 0/2 should be on VLAN 20. Okay. 0/2 switch port, access VLAN 20. Okay, and go here and then do the config as 20.0.0.1. And here. .0.0.2 here. Okay, so let's look at the IP address here.
So to config the IP address, we are clicking the right click for in the keypad or what?
No, just the regular click. Just click and then
Okay.
go to config. No right click.
Okay. When we will be starting the lab, sir?
It's free of cost. You can go ahead and just Google it and download it.
Oh, okay.
But I will send you the link in the group, WhatsApp group, where to download it. Okay.
Okay.
I'll send
Okay.
it after the class.
Yeah, that's what we were getting a little bit confused. Like, we don't know the user interface, how to use, where to click, and what keys we need to use while going on the lab, right?
Yeah, you'll get there. So on the switch, now I have to check show VLAN brief. I have VLAN 10, 0/1 on VLAN 10, okay, and 0/2 on VLAN 20. So that is all good. So now I have to create the same thing on this one.
Sir, could you please explain those commands, what you are using on the console?
I just did. Which command you're looking for?
VLANs, how you are creating the VLANs?
Yeah, so to create the VLAN, I have to do, let me show it here. Okay, so to create the VLAN, you have to do config terminal, that is to configure something. You have to do VLAN space 10. That is the command to configure the VLAN, and then you have defined the name. Okay, so that is the name of the VLAN. And then VLAN 20, that is how to create the VLAN, and then name as 6. Okay, to check the VLANs, show VLAN brief. Okay. Okay. So now I have to attach 0/1 to VLAN 10 and 0/2 to VLAN 20. Okay. Quantity again. Interface. Fast Ethernet 0/1. Switch port mode access. Switch port access VLAN 10. Exiting from that interface. Again, interface. Fast Ethernet 0/2. Switch port mode access. Switch port access VLAN 20. Okay, so now this port is in VLAN 10, this port is in VLAN 20. So now the port between these two should be the trunk port, right? So this should not be the access port. So I have to go there and then create interface FA 0/3. I have to do switch port mode trunk, switch port trunk encapsulation, switch port trunk allowed VLAN 10, 20. So if I do show run, it will show you what I did the configuration. 0/3 as access VLAN 10. I have to remove that. I think that's from the previous config. So let me remove that. No switch port access VLAN 20. Okay, so I have switch port mode trunk. Switch port trunk allowed VLAN 10, 20 on the 0/3 port. I have to do the same thing on this switch. Switch port mode trunk. Switch port trunk allowed VLAN 10, 20. So what we have done is we did this in the access port and we did this as the trunk port and we allowed both the VLANs on the trunk port. Okay, so if I do show run, it will show you what configuration that we did. So 0/1 is in VLAN 10, 0/2 is in VLAN 20, and 0/3 is a trunk port, switch port mode trunk, and trunk allowed VLAN 10, 20. So this one is in VLAN 10, this one is in VLAN 20, this one is in trunk port, allowing both the VLANs. Similarly here, 0/1 is in 10, 0/2 is in 20, 0/3 is a trunk port allowing 10, 20. Okay, so 03 is trunk port. Okay, so now we have to make sure the VLAN 10.10.0.0.1 will be able to reach 10.0.0.2 on the right hand side, which is in the same VLAN. Similarly, VLAN 20.20.0.0.1 will be able to reach 20.0.0.2 on the right hand side. Okay, so let's go here. I'm deleting arts because we are, reusing the old lab, right? I'm just clearing everything up. Okay. All right. So now I'm here. I'm doing the simulation, and I will be generating a ping from here to here. Observe that the VLAN 10 will come here. It will not send the packet to 20 VLAN. It will use the trunk port. It goes there, it goes here and get the response back. That is how it should work. Okay. I'm going to start the simulation. I'm going to go here and then do ping 10 dot. Let me make this smaller and bring it here so that you will see, or bring it down. Okay, I'm going to start the ping. So the broadcast frame is starting from PC0. It's going to the switch. Because this is a trunk port, this should be sent over the trunk port with the VLAN 10 value. Now it should not be sent to this port. It should be sending to only this port because this is also in the VLAN 10. It went to PC4. The response came. It should be sending with the same tag to the back switch. And the response should go back here. Okay.
Sir,
So now,
sir,
yes, go ahead.
there we make a simulation just by pinging 10.0.0.2. But how it started from PC0? It could start from PC2, right? Like how it decided by itself. We just mentioned that.
No,
Yeah.
I did go there and generated a ping on PC0.
Acha, okay.
I am the one
So we
who
are,
went to PC0 and generating the ping.
we are making simulation from PC0.
Yes, we
Okay,
are
okay.
generating the traffic from PC0.
Okay. So in the same way, if we start simulation from PC2, it makes the same thing. It goes to LAN 20.
Exactly. Yes.
Yeah.
Yes. Okay, so now I'm going to stop here. Now like you asked, I'm going to go to PC5 and generate the traffic to PC2. Okay. Um, 20.0.0.1. So I'm pinging from PC5. It generated the broadcast message to the switch 1. Now it's a trunk port. This should go all the way over the trunk. It went to only this switch, this PC. It came back, and that response is coming back, and that will go to the PC5. Now tell me, will PC0 able to ping PC4?
What's the question, sir? Will PC0
able to ping PC4?
Yeah.
Yeah.
Because those two are in the same VLANs.
Okay. What about PC0 talking to PC5?
No chance. Because it will decline this tag.
Those are in different lines.
Okay, now let's test that. Okay, so I will log into PC0 and then try to ping. What will be happening?
20.0.0.2.
Yes, that's what I wanted to do. So I'm going to go to PC0 and then do ping 20.0.0.2. Yeah.
So here the tag goes until switch 1, sir. When it goes to PC5, it will decline.
Yeah, I'm gonna show that 1 second. Let's and now okay. So here this is an access port, right? So I'm gonna start the simulation and start. Go here. If you see, it is just trying to reach to the switch 0 and it is never going anywhere after the switch 0. My packet is getting lost because if I generate the traffic, if I see packet sent, received 0 and lost is equal to 1. So I'm gonna go here and then stop real time and then start generating again. It says the request timed out and it couldn't even reach the destination. It is just into the switch and the request is getting timed out. That is what happening when it's trying to reach PC0 to the PC5. So they are in different VLANs and they are not able to communicate because we separated the broadcast domains and they cannot reach between them. And the only way to reach between them is using a layer 3 device, which is called a router. So for tomorrow class or day after tomorrow class, we will make these two communicate by using a device called router. Okay.
Yeah.
So a router will make two different networks connect between them, but a switch cannot do that. A switch will only able to connect different
In the
devices
same
in the
network.
same LAN. Okay. All right. I'm going to stop there. I'm going to pause the recording and I'll leave the floor for any questions. Hold on.
Sir?